Hello, everyone. Hi there. Let's see who is joining. Yeah, while people are joining, let me introduce myself. Hello, everyone. I'm Gunjan. I am founder of Bytes and Base, and today going to talk about something that keeps all AI engineers up at night, like taking AI systems to production. Yes, but why? Why we're here? Why we're talking about this? So, a little bit background. Like I have been in this industry, like deploying data and AI applications for 15 plus years, and I built AI applications before it was cool. So I built these systems into enterprise scale companies handling 10 to 100 million requests per second. So our approach at Bytes and Base is exactly that, combining Gen AI advancement that we see today with software engineering principles. And result is scalable, reliable AI applications for your business. So, but let's again answer the question: why so? Why we need to talk about production applications? But let's see, with rise of Gen AI advancement, and you see AI writing code and tools like Cursor and Claude, they're amazing. I use it all the time. It's my favorite. But and you can also see from many people, right, that you can essentially build an entire full stack application MVP of your product in a day, maybe less. So why we need to talk about production? If you can handle these systems and you can build your application from one prompt by the time this live stream is ending, so why we need to think about production at this scale? So reality is building software, yes, it has become easier than ever. Like Cursor, and I also experimented Bold.new, that is new application. It is amazing. And it is amazing for getting ideas out of up on your head and without having any engineering background. So that's very powerful. And you can probably go to market with the solution as well and test out and see, get user feedback. And what I see from this other advancement is this nothing new. Like I compare this to like no code movement that happened, remember 2020. So this is something I see similar to that, like web bubble or webflow or whatever you call it. Like you can, have power in your hands, and you can get ideas out of your head and build applications and go to market with it without any engineering help. And that's powerful, and that's really, I would say, useful in the. But however, like if the best case scenario happens with your applications, like which might be your app going viral, now you have hundreds of thousands of downloads overnight. Now what happens? So, can the same systems that you built over the weekend, can they handle this scale? Maybe, maybe not. It can handle if and only if, like if your applications is built with this scalable architecture in mind, or it has considered scenarios of scale, basically, let's say that, and your design architecture accordingly. Yes, it can handle those scales even with your no code MVP. So what that tells us, like underlying, we need to understand, like yes, while we can build a system, we also need to understand the infrastructure that it runs on, and how it handles and how it works with, like, me talking to a chatbot versus 1,000 people at the same time talking to this chatbot also. So how that works. And this is not AI problem, really. Like it's not like AI is not advanced enough to handle this. It's really comes down to the software engineering principles and architecture. And that's exactly what we need to talk about today. So let's start by sharing. Yeah. So this is what we're going to talk about today. So what basically you're fascinated about today? Like which stage of your AI journey you are on right now? Like just think about that. Like, are you building prototype, or are you just experimenting with the idea, or you may be in development already? That's great. Or you might be already launched and you are in production. So what, based on whatever stage you are in, I want to think about that and think from that angle about this presentation, and ask questions. Like, let's make it more interactive. So, and it, you can see like every AI project goes through the same journey, like yeah, it's magic, to oh no, why it failed, we don't know, we have no idea, versus okay, it's finally taking shape. So it's okay, like, whatever journey you are in, and we can talk about that further. If you have any questions, I'm monitoring the chat too, so let me know in the comments. Okay, so what I'm talking about here, like what MVP is and what is the production system. So yeah, let's take this example, like spot the difference. What's the difference between these three? Right, it's a paper plane. One is supposed to be, I think, a remote controlled, highly advanced toy plane, and one is commercial airline, of course. So where do you think we are in journey? When this represents where we are in our AI journey these days. So I would say personally that we are way past the paper plane stage. We are more or less with the highly advanced remote controlled toy plane at this stage. Like yes, it is amazing. Yes, it's advanced, but and it can also fly a couple of miles. Even I don't know, it is really good. But can you cross Atlantic with it? Can you put your life in the hands of this plane? Maybe not, right? That's a whole different challenge, and that's where like a commercial, and that's all exactly the problem is. AI alone is not going to take us from this stage to this stage, but underlying principles and the architecture that it sits on can make the huge difference. And it is that the AI must be along with all the software engineering principles and architecture that builds scalable distributed systems that we have been doing all along. It's nothing new. AI is maybe now a tool in the toolbox, highly advanced one, but it's still a tool. So scalable architecture pattern is what gets us from this toy advanced demo to production ready application that crosses Atlantic. So let me tell you the real customer story too that I was working with, like with the chat corp, let's just call that. It was customer support chatbot that we are building for them. And yes, the demo, we built it. It's amazing. It answered questions perfectly. It has 2-second response time and even less, I think. Then the cost was, a couple of dollars a day, and that's amazing. Everybody loved it. And so we launched it, and 2 weeks later, the success happens. Everybody loved it. Adoption rate increases. Now, what happened to this chatbot? It's still working. It's amazing, but now you see that response time went slower. The chatbot is taking a lot longer to respond, and cost, the API cost became like $500 a day without nobody knowing that where it's coming from. The bad actors, they also show up, and success, it happens. Some customers were trying to prompt hacking it, if that's the word, and yeah, a lot of troubleshooting that needs to happen. So it is not a failure of AI in a way. It's not failure of technology in a way. It's just the production readiness was not thought through. So what does production readiness really mean? You might ask. Is like, what is the difference? Prototype and production. So like given this customer chatbot example, right? What are you trying to achieve? Like you're trying to achieve a personal assistant, a support desk person. Now imagine that one person can handle one request, one customer call. Great, amazing. Can the same person handle 10,000 customer calls? Maybe not. So, what, like, you might argue that, yeah, it is a human limitation, and now we're talking AI, but AI alone, as I said, not going to get us there, right? How to make that AI system handle 10,000 customer calls at the same time? That's where the real magic is going to happen. And that's what we are calling it armor frame. It's just the framework that we have created. I'm going to talk through the whole system, but it just ensures that we are production ready and we are able to handle scale, and how we are building it. So that's what we need to talk about today. So let's continue our example of customer support chatbot, because that's the application we have already built with this architecture, and it's a blueprint and it's ready to go in production. So customer support chatbot, like what it should do. So it should answer some basic customer questions about the company, and learn from the interactions. Like we want this chatbot to get better and better every day, not stay the same. It can scale if this is successful. It should be able to handle a lot of queries and without adding too much cost on the API, hopefully. And most importantly, I think this is the most overlooked part, is answer ethically and reliably. It should not make up stuff. It should consider all the data privacy rules, and it's not optional. It should consider all of this compliance related policies and ever changing AI. It should have all this inbuilt. So yes, let's tackle how we can build this step by step. And let's start with the stage one. Really, that is one person, one customer talking to the chatbot, asking only one question and getting only one response, like simplest use case ever, right? So single user stage, that's where we are in right now. We are not overcomplicating it. It's one system, one user. But as you can see, there are still problems that might happen, right? So if hallucination, even if it's one question, LLM can still mess it up. It's not about scale at this stage. Like if you can ask, what is your refund policy? And it just completely mix up the whole stuff that is not in your refund policy. But now chatbot is going to say that. So that is one problem. Another is response time. Is that it might be too late to answer. So customers are going to get frustrated, like why it's not answering. And yeah, not a great customer experience. Cost per query, cost impact, huge. Every question that customer asks or a chatbot response is a query to LLM. And each query cost based on your token. And that's the whole other topic that I can go into deep. Let me know if you want to talk about that into future sessions. I can certainly do that. But multiply that by now thousands. So that can go out of hand very quickly. And no learning customer interactions. If chatbot made a mistake, we want to make sure they at least don't make a mistake next time. So this is similar to what you train your customer support agent, the human agent, the intern. If suppose like that's what you're going to train them, that hey, you made a mistake, we need to give that feedback so that they do not make this mistake ever again. Same concept applies to chatbot too. Like we have to make sure that this thing learns very quickly and it continuously improving itself. So yes, that can happen even with one question. So how do we improve from here? So next stage is going to be, let's add the basic protection. So basic protection, what it means that it only going to handle few of these. It's not going to hit all of them, but we'll try, right? So let's see how it can handle just the basics. So what do you see here? It has validation layer and cache layer. Like what all those words means. So let me explain one by one. So same scenario, customer is asking what is your refund policy, and it goes to validation layer first. So think of it as security guard, and it checks like, is it your valid question? Is it safe to process? Are they asking relevant question for from the context that we know that customer is supposed to ask? They're not asking for how to book flight or something else, right? That is not in our context. Excuse me. And it is coming too fast, maybe. Like if somebody is like hitting our systems at, you know, lot of requests and trying to choke it. So those are the things that validation layer can handle. And once it passed the security guard check, okay, it's good. Let's go to now cache. Now, concept of cache is institutional memory. So before, as I said, okay, every question that you ask LLM is a query. It's going to cost. So what if before asking this question to LLM, we can check in our institutional memory if anybody else has asked this before, like what are your hours of operation? I'm sure many people have asked this, or we anticipate many people are going to ask this. So why not store it ahead of time? So that's what cache does. And if it is cached, this response is cached, so we do not have to go back to LLM all the time. We can serve the responses just from here. This alone, I will tell you that going to hit your 30, at least 30% less calls made to LLM, just because you implemented caching layer. So do not ignore this. We use Redis for this, and it works like charm. Then the response router. So you might say a small model, large model. So what does it do? So it simply decides like which model we want to talk to, right? So if it is like simple FAQ stuff, what is your hour of operation, or something very very simple, straightforward, you do not have to hit GPT o1 or 4. You do not want that. You can direct it to very simple model. If it cannot, it don't even have to be LLM. It can be something very FAQs. So that can be served from the smaller model, like a simple question, but some like more complex questions, like customer is asking for some feature related request that might require chatbot to go to the knowledge base documents and retrieve the information and compose the response. So that can go to large model. You can use GPT-4 or advanced model there, but it also costs more. So just by this routing simple mechanism, I can say that another 30% you can hit and reduce your cost to LLMs. So just by adding this two, I think we can increase our protection a lot, but we can do better. No, so let's add one more layer. It is doing the routing part quite easily, I would say, at this stage, but it is still not intelligent. It's not learning anything. It's still staying the same. It's just answering question that is asked to it. Now, what if we want to make sure that our customers, when it just remembers the customer that, hey, you're back. Like, how was your problem we saw last week? Like, it will be much more personalized, right? And that's what AI is supposed to be good at. So how can we make sure that AI handles that? So let's add third stage onto this. And it is adding the intelligence to our AI, right? So yeah, how it looks like. So you already know, we explained this part. So input, this is your context manager. It understands your user's history, maintains the conversation context, and processes the query efficiently. And then smart routing, it can decide where to go based on your query complexity and customer and their history. And this is the feedback loop that we need to introduce on into the conversation that runs alongside it, and that is the continuous improvement engine. So what it does, it collects the user feedback, like whatever interaction is happening. If customer says no, that's ridiculous, or no, it's amazing, whatever it says, it can collect this feedback and uh, you know prepare the training data accordingly. It can, if you know how to train an LLM, you know that you have to add your text, add your context, and you add your labels on for feature engineering, that you add your labels that can effectively determine that what type of response it is. It is positive, negative, and anything like it. Many ways you can feature engineer these responses, and that you can do it here by preparing your training data and fine tune the model. So each model, now you can fine tune based on your customers' data. What type of responses gives us good feedback from customers. So we need to do more of those. That's where system learns how to handle customer requests, model fine tuning, and then update the model. So next time when new request comes, it uses the new model. Now I put it side by side because this is not happening all the time into our system. This is, maybe this part is happening in our system, feedback loop, and get prepare the data and get it ready. And the fine tuning job or model update, that might be happening like overnight and as part of nightly job. Really, it's not real time. So just keep that in mind, that you do not have to over engineer this. Like, just make sure that whatever interaction is happening, we're storing it somewhere into a database in somewhere, and the data is getting cleaned. It's we remove the, as we talk about data privacy aspect, like we do not want to store anything sensitive, but we can store the interactions and insights from that. So that you can definitely do. And jobs, schedule it for later. That's what adding intelligence looks. So now it's already got better. From we started with the first thing, that was we can answer anything and we don't know what's going on, versus now we have some control over our system, and we are handling hallucination, we're handling cost. But is this is still not scalable? Like, if this is still, I think, happening with 1 or 100 or 1,000 users, but what if you have 100,000 users or more, or you want to make sure that your system is capable of handling that spike, Black Friday? What happens if you have like a lot of customer queries that is not anticipated before? Your system should be able to handle it, it should not crash, right? So that's what we need to now think about, how we handle this on Black Friday. So let's add the now another layer into our architecture, that is how it scales to millions of queries. Okay, so this looks complicated, but I promise I'm going to explain this. So I hope this is much better. Okay, so scaling, how the scaling works. So what scaling really means, like, let's just first understand the scaling part, right? When I say that we are scaling our system, what that actually does. So scaling in software architecture really means is the process of executing linearly, like one process does the one job. Rather, it is now broken down into multiple chunks, and it can handle by thousands of processes. That's what it does in architecture terminology. But like, let's take example of like restaurant. Like, you have one chef and one waiter that can handle 20 customers per hour. Great, good restaurant. But now what happens? Holidays or something else, that you have like a lot of customer coming in, the restaurant got really famous, you need to handle scale. That's what the scale really means. Now, there are two way of doing this scaling. Like, if you can add bigger kitchen, you can have bigger ovens, and you can have better equipments and better hardware if it is software applications right there. So yeah, it can give you lot of power of running restaurant. Like, you can have bigger oven, but might look like to some people is like throwing money at the problem, and it will work temporarily. It will improve your performance, improve the how many cakes you can bake. But another layer is the horizontal scaling, that we call it in software architecture. It's like break down the problem. It's like multiple small kitchens are created dedicated for a task, like chopping station, cooking, whatever stations, or multiple kitchens. A chef handling each station or one kitchen, multiple wage staffs, and there can be one manager too who is managing the whole operations. Right? You cannot just let everyone do its own thing, and it's nothing is combining at the end of the day. So that's not very productive. So you need a manager or a coordinator that makes sure that whole process is orchestrated properly. So what it looks like in software applications is like you have multiple servers that can handle the request, and based on which server is good, which one is sick, like which one is on sick, so we have to replace it with another server. So things like that we have to handle, and they need a balancer. So that process is called load balancer. And in this, you have like maybe 1,000 requests, 1,000 people trying to chat at the same time. What happens? So load balancer is going to take that request, all the like funnels into this one, and load balancer will decide that which server should I send it to. Like, one server is already loaded, we should not give it too much load. We can give it to, and there are multiple ways and thousands of algorithms to do that. But let's just take the simple example here. So what it does, like multiple entry points, It automates the balancing of the load, like where to go, health check, and fail over. Like if server 2 is down, give it to server 1, replace server 2, things like that can be handled by this manager. So Black Friday traffic, yes, it can be done it this way. And when there is no Black Friday and it's normal day, you can maybe cut down one or two server and save your cost that way. It can automatically scale up or scale down too. So that's really powerful. Queue management. So queue is just think of like a bus or like a pipe that is flowing your traffic. Can say as a traffic shock absorber. So it can handle the spike, prioritize this request, manages back pressures, and yeah, system get like 1,000 requests per second, process them smoothly without rushing it down, and pushing into separate pipes that are dedicated for certain requests. Like if it is FAQ request, if it is those kind of thing in terms of scaling. Cache, as I said, like we use Redis. API servers, it can be just our normal web server. And yeah, the scaling and the caching itself can be distributed cache in real architecture world, like your speed and cost optimization layer. So it can be globally distributed cache, like if somebody is you know uh, putting a request from Europe, for example, they can be served by Europe cache so that they get the response faster that way versus the US servers. So things like that, it can be handled with distributed cache, preemptive caching, and smart invalidation and things like that. It can be like really effective if it is used correctly. And your model management, like multiple model variants and automatic selection and storing into database and model registry, like which model to pick. That this can have its own, you know, architecture and infrastructure to handle this and serving the model too. SageMaker is the most popular one. We use SageMaker all the time. Our fine-tune models, Llama fine-tunes or ChatGPT, and any of the model, like we can definitely deploy it on SageMaker. And we are, let me know in the comment, like if you want to know more about this, because I'm planning the next series of streams specifically on MLOps, like just for machine learning operations, like how this whole process works. Cannot cover everything in one stream, so I want to break it down. Let me know if you have any specific concerns around that. So yeah, that's what overall blueprint architecture I'm calling it, because this is not only customer support chatbot situation. It can be any architecture, like any software or AI applications, like content generation, SaaS, or image generation, or voice agents. Any of these applications that you're building can use this architecture. It is a blueprint, and it's production ready scale. So yeah, you can basically take this out of box and implement your use case. Like you do not want to buy microwave, so you can focus on building your recipes, but microwave you do not have to build from scratch all the time, right? I mean, that's the whole point. So that's what we're trying to do here. We give you this microwave, so you do not do this from scratch and reinvent the wheel all the time when you're hitting the plateau in your AI applications. So yes, that's what this looks like. And yeah, let's move to the real world challenges that are specific to LLMs and how it might look like. So let me share my code, for example. Yeah, let's just go with like what I'm trying to show here. So hallucinations, first of all. So hallucinations, we know is a real problem, and let's dive a little bit deeper into this problem, like how we can even scale this. So hallucinations, this is basically what how to handle hallucination looks like. A user query and context injection and prompt. So this is what your AI applications are uh, coming from user. Like this is the input coming from user. Now, first thing it will do is do confidence check. That is it, like this is looks okay. If it looks okay and it is not a bad request, then it is counted by confidence score. So what is the confidence of yours, like on a scale of 1 to 10, how confident I am that this is accurate information. So that's what basically confidence score means in machine learning language. If it is low confidence, then it goes into fact checking more. That is it real? Like it doesn't look, I'm not too confident that this is my response. I'm not too confident. Is it okay or not? So that goes into more fact checking and more validation. That if it is okay, looks okay, I find that fact, let's add that reference link that I found on the internet and validate my response based on that. Now if it passed this validation check, then you give that response to the end user directly. Or if it is not, if it failed that validation, you do not have to uh, say something wrong that does not exist. So you can prepare some fallback response in that case. Like what if scenarios, like yeah, like you might have seen from LLMs that as an AI model I cannot say whatever, right? So that's what the fallback response it looks like. And ultimately everything goes back to user feedback and train the model accordingly. We could not answer this question and everything like that. So this is basically the hallucination, handle how we can handle hallucination. So let me share something else too in the code I wanted to show you. And right, yeah, so right, this is like the validation response that we have developed in our blueprint that I'm showing the architecture for. So validate, it checks for the fact checking. So each of this line item also has its own implementation on top of this. And policy compliance is compliant to policy. Data privacy, it is not saying something that it should not, and all those responses. And the safety check too, that it is not saying something that is inappropriate. And all of this have its own input and output response and implementation. So after all this checks are passed, then only it's going to go back to the system and say yes, all looks good, you can send this response to end user. And it checks the confidence score of each response regardless too, that yes, I'm saying this is correct, but and this is how much confident I am based on that. So if you have extra implementation on top of that, that if your confidence is below 5, then you should also add this disclaimer or something like that can be implemented this way. So yeah, that is what basically what we need to do. And let me go back to the slides one more time. Yes. And cost management, I think we already covered how this works. But yes, check the complexity and check the which model you want to direct it to, and based on each model that you select, it can have its own cost associated with it. So we might want to keep an eye on that as well. And third is continuous learning. I'm not sure why I can't zoom it further, but I hope you can see it. So continuous feedback. So this is like a one layer deeper into continuous learning that we saw previously, right? So this zoomed version of it. So user, this is where the data collection happens. This is model improvement section that happens, and this is the deployment to production. So collection part, where it happens where the interactions are happening. Where the interactions are happening, we collect the user interactions, we collect the feedback, and we process this data. So that's everything happens in this process. The model improvement section, that is where the improvement happens. Like whatever data we have collected, all this process does is just collect everything. It is not doing anything intelligent, system way. That happens here, improvement. So here we are taking the data that we already have, turn it into training data, fine tune our models, and A B test it also. Okay, some models, like you want to use like multiple models. One is fine tuned with certain data, one is fine tuned with certain data, and test again in real time that if your systems are, one type of responses are more preferred versus other, you have to do that too here. And ultimately deploy. So deployment is this whole section, as I mentioned. I want to do this for the streams on MLOps. So let me know if you want to learn more about that and what specifically, so I can include that. So after a model is fine tuned, you need to serve the model to production. So that goes into your deployment cycle. It updates your model into production. If it passed, great. If it fails, we need to refine it a little bit more and goes back to training it, and the whole process cycle continues. That's what basically what it means. How to handle your systems at scale in production with continuous learning. And if I can show you the code again. Yes, so this is how it looks like. Yeah, feedback loop section, right? So this is what feedback, the collection looks like. So each interaction we are getting from the, our interaction, the chatbot that people are chatting with, and prepare the query. What is the response? What the user has asked, what the LLM has responded with, what is the feedback. If user already, sometimes so you can add the feedback mechanism there, that have you, are you satisfied with this, give thumbs up or thumbs down. That can be recorded here too. And the time to response and all the other metrics, the confidence score and cost per query, everything we can start collect. So this is all that does, everything is collecting and saving. That's all it does. Then improvement happens after that. So each one of these have its own implementation, like it is its own feedback, and its own method. In software world we call it like a function. So it everything is different. We can go deeper into that. If you want to, let me know. And yeah, that's what this is doing, the improvements based on whatever feedback we got. Now we're analyzing the feedback, like, based on, is sentiment analysis, if it is okay, not okay, positive, negative, whatever else. And if it is update is required here, then we update our models. And we do a bit split the data into, different type of responses, and do A/B testing on those models too, so that everything happens behind the scene. And this is how it is implemented. uh, let's go back to our presentation so that we can now talk a little bit more about how it is, how it is deployed. Basically, that's where we need to be. So this is what the architecture looks like for scalable system in production, right? So I understand that it is really, overwhelming right now, but don't be. It is not. It is conceptual. It's concept wise. You need to understand that this we have to think about. Implementation, we do not have to worry about it. There's still the, things are implemented, whether in other, you can say, GitHub repositories, or we have our own GitHub repository. We have everything right there implemented. All you have to do is add your customizations in the feature side of it, and take advantage of that way, but we want to make sure that this exists. And this is how you should think about implementing your AI applications at scale that is reliable and that is implemented for your business. So yeah, now that we know, these are all the like little components that we have to think about: load balancing and validation check and hallucination check and A/B testing, everything. Like, you might argue with me that what if something fails, right? Things can fail and things will fail in production, like data processing job, like this job failed. How do we know? And more important, how do we recover from that? Like, what to do? This failed, now nothing can continue after that. So we're stuck. What happens? Well, first thing we need to do here is monitor all of our components that we have built so far in our architecture. Each one of them we have to monitor. And what monitor really does is it just checks that it's there, it's healthy, and there are multiple like metrics that we have to consider, like similar to your business metrics that you consider, like what is your return on ad spend and what which ad worked or not and how many click through rate and all that. This is engineering side metrics that you have to monitor for any AI application or any application that you're building. So for this chatbot application example that we're talking about, I have divided in like three categories in a way, like what we want to monitor in terms of metrics. So system metrics is one. System metrics is basically means that I'm alive, I'm up and running. My response time is this. Our we are not failing, and our queue is good, and our cache is good. It's not getting full, and our servers are okay. Everything is okay. Like everybody just gives thumbs up every few seconds, so system knows that okay, it's alive. That's what all this metrics comes into picture. Then comes business metrics, right? That we want to keep an eye on. We might have some guardrail that I don't want to spend $50 or more into today, this for this day for Black Friday we might increase it. So these are some like guardrails for business wants to put on. So that's what the matrix looks like here. Like, what is your cost, how much you have spent already today, how many requests you have served, what is the quality of your responses, and how many errors, if there are any validation error occurs and it requires a human expertise. That's where you might also have to monitor that this is what this how many responses we needed human to oversee. So all this like business related metrics that you want to monitor. And third is LLM, like AI specific metrics, like what is the model performance, what is hallucination rate, how many times it hallucinated today, what is the cost per query that we spend, and what is the confidence score of each responses that we are you know giving from this. So that's what monitoring looks like. And this is, if you feel not clear, do not worry about this. This is the whole different another section called ML ops that I will cover. So if you from now on, if you do not understand this part, don't worry, this is going to be discussed a lot more in detail later on. And the deployment, so how this everything is tied together and deployed to production. Like, yes, building a code is one thing, but what happens when you build the code? Like Claude wrote you a code, or Cursor, you build a code with that. What happens after that? How it gets deployed to production and live in customers' hands? So this is normally how that process works. You might have already done this before, or you might know concept about it, but this is how generally happens in production. So code changed, something changed, you change, you figure out that this is this is not good, we need to improve on that, you change the code. Then you go to testing. So testing, it is just double checks it what you have already done, that it is working. the one part that you changed did not impact the other 500 parts that are working also in the same system. So it just checks the overall stability of the system. Then it staged the deployment. And now what happens after staging? It does the A/B testing based on what, as I say, like some things you want to deploy only to certain customers, like beta users. Something you do not want to go live with. So, or if you want to go live with, you want to test two different versions of a model. That can happen with this A/B testing. It's optional. Don't have to use all the time, but this is good idea initially to do that so that we make sure our model gets better. And based on that, if something fails here, like we find out in testing that whatever changes you did, it's not good. It is breaking this other system that we are also responsible for, so not a good idea to deploy this. So it does it rollback. So your code does not get updated in production, it goes back to the previous version. So whatever customers are interacting with, they do not get impacted with this. If it is correct, if all is well, then it goes into gradual rollout. Sometimes we do it canary deployment, sometimes it just gets deployed production to all users at the same time. But this is a good practice to have a gradual deployment that is does the performance testing, that does the cost, it does the quality checking, and it does the if it is good for like 10 users, then we go to the another 100 users, things like that. So that is how this pipeline looks like. CI/CD, again, part of MLOps, will be covered much more deep into this. But after all this is done and it's deployed and it's amazing, it's working, what you should be doing is also like documentation and knowledge management. So things like this system architecture, we need to document it, what our system is. So any new developer that we onboard tomorrow also knows what is going on in our system. What are our operating procedures? Like what if something goes wrong? Like who is responsible for that and who does that? How to fix those issues and all the playbooks that goes. All these things I recommend that you need to uh, you know properly document it and create an SOP around it. But uh, how to even get started with this implementation? The good news is you do not have to start from scratch. These are the blueprints that I have already created, and I can even show you this right now. We have already created the this blueprint, and you can get access to our repository also, so that you do not have to build anything from scratch. This is our GitHub repository that we whatever I have talked about, all the architecture and validation, everything is implemented right there. And this entire GitHub repository you can get access to and build your own solutions. So it covers everything, like your API and authentication. Like if you want to log in with Google, log in with email address, it is also implemented and covered. Real-time chat updates, admin panel to monitor all the interactions and what is happening. And yes, all the tech stack that we use, the latest tech stack that is scalable and proven into the real world environments, into enterprise applications. And we also, this is still just the example, but we'll also give you the detailed implementation guide, that how to implement. And you also get the our hand holding if you want to implement this in your system. So let me know. We have a link in the description below to just reach out, and just we can go over this and how it might look like into your system. So yes, this is exist. As you can see, everything is built out and it's ready to go. Basically, all you have to do is uh, you know dream up your idea and how you want to build this into your system. So how it looks like, right? Implementation, like what normally I suggest that you do if you are building AI applications. You might already have some AI applications and you want to Now scale it to millions of users. So audit what you already have. You Chances are you might already have many things in place and you don't even know about it. So your existing AI application against our framework, we can help you there too. Just see where you are, like, create a baseline for your journey, and then set priorities, like which one of those features are critical to you. Is like creating a feedback loop is more important to you right now, or reducing cost is the priority. So set the goal. Like you're not going to get to the final stage, or there is no final stage. It just what matters is what matters for your business today. So set priorities, identify the critical areas that needs attention right now, that you can get to achieve a quick win with it. And then implementation, that yeah, use this blueprint, or there are other blueprints out there too, so use that. At least main thing I want you to take away is this is how you should be thinking about AI applications if you are building it, and how you do it is irrelevant. And continuous improvement, I think whatever you do, whatever your priorities are, make sure that you collect feedback, start collecting the data about your systems, how it performs when there are 100 users, how it performs when there are 1,000 users, or what type of responses get, what type of quality of your application is. So even if you are not doing anything immediately, I want you to start, at least start collecting data around your system, so that you can see it and optimize it later on. So continuously assess and optimize, and yeah, start slow is what the recommendation generally is. Start slow, learn from it. Let's see, collect data, and then implement changes as we see, progress. So that's what basically it looks like. This is my own roadmap that I have created. This blueprint, this customer chatbot, this blueprint that I have created. So you might not see this. I can't zoom it out, but yeah, it started like we started in January, like what the basic setup is, and what the scaling components we built it over time, and error handling, like all the like layer by layer we added the you know features and complexity into our architecture to where it is now that I'm showing you today, with monitoring, with metrics, with fine tuning, with serving, everything is already built out. So it took at least 4 to 5 months for us to build this entire architecture. But you don't have to do that. You have everything like built out, and there are blueprints. So I want you to take advantage of that. So whatever we have built in 6 months, you can go live to go to market within 2 weeks. So you have done all the hard work. That's the good part, right? So why reinvent the wheel? So yes, this is what we can help you with. If you want to use this blueprint, let me know. Reach out to us, and yeah, we can deploy this architecture with the source code and the documentation and deployment and monitoring. And we can also have like white glove onboarding support and technical consultation for you, like to implement this into your business. So that's what we can do today. And then I cannot wait to learn more about like what you are interested in and what type of applications you are building. So reach out to me regardless. Let's stay connected and let me know if you need any kind of, feel free to reach out. We're passionate about helping teams succeed with AI and succeed scalably and reliably. And we would love to know what you're building today too. So thank you for having us today. And yes, I want to see where this goes. If you have any questions, please let me know in the comment section or into here, so that I can answer right now, or anytime. Like if you go back and you figure out something else, like please let me know. My details are in the description. So let's stay in touch. Okay.